When working in object-oriented programs like C#, you will hear a lot about classes and objects. Since visual scripting is built on and leverages off existing C# Unity code, this applies to visual scripting as well. A class is a blueprint of something physical you want represented in your system, like an animal or a car, or it can be something that is a bit more abstract, like an online banking transaction. A class has attributes or properties. Using our animal example, we can define properties like eye color, fur color, the type of animal it is, or the breed. A class also has methods. These are actions that can be performed. And this is where the important work happens. For our animal example, we can define methods like walk, run, or sleep, among other things. Now, where a class is a blueprint, an object is the actual creation. An object is created from a class. From one class, you can create many objects. We say that an object created from a class is an instance of that class. Each object will have their own unique identifying attributes, or perhaps they could all be the same. What's important to note is that each object represents an individual item or entity. So, just like you as a person are an instance of a human class, for example, with your own unique traits and behaviors, you can also get identical twins who have the exact same traits and behaviors, but they are still each their own unique individual. Now let's do something a bit more interesting. Let's have a look at one of Unity's classes. We are going to manipulate this in Unity after we're done here with this section. One of the most common classes of Unity's you will use is the transform class. A few of the most commonly used attributes of the transform class are position, rotation, and local scale. We will be using just a couple of methods, and these are translate and rotate. And that's to move and, well, make an object spin. So let's have a look at how we do this in Unity. So I'm going to create a new object, 3D object cube. And just in case you guys have forgotten, let's have a look at the transform. So on our cube, we've got this transform. And any object that you create in Unity, any game object, is going to have their transform by default. So if I create an empty, which is the simplest game object that you can create, it is going to have the transform component. Okay, I don't even think you can remove this one. So all your game objects has to have a transform, which Unity creates for you. You don't have to worry about actually adding it on ever. Okay, so transform has position, rotation, and scale. And that means movement. So let's just zoom in a bit. Movement, rotation, you can see the values changing over here. So I can manipulate these values in the editor. Let's update the scale. So I can click and drag on these, as you know, to adjust these things. I'm just going to reset. So if you want to reset something, so you see I've made a bit of a mess here. Reset, just click these little dots on the top right corner of the transform, and let's see what translate does. I'm going to create a new object. Let's create a sphere this time. Hit components, script machine, click new, vscripts. Remember, vscripts is for visual scripts. Because I'm using C# and visual scripting, I just decided to differentiate that, and let's call this translate. Open that up. And I'm going to get rid of start sphere. Just make sure your sphere is selected. Okay. Output node, click and drag and click again and search for translate. you'll see there's a bunch of methods again. They're all quite similar to each other, but let's just choose a simple one here. Let's just choose this one here with XYZ, and we want to make it move to the right, so let's give it a small value like 0.1, and this should work. Okay, even with 0.1 it's moving too fast. Let's make it 0.01. That should look better. Okay, so that's moving along to the right. If I change, say, Y to 0.01 as well. Okay, what did I do? I don't think it accepted my input there, but now this should move up and right. Or diagonally up, right. Okay, so that's simple. Let's translate. And now you might think you're going to use this all the time for moving your characters around, etc., but actually not. Translate is used in quite rare occasions these days. So for any type of game, say you're making a platformer or first-person shooter, you're going to use something called a rigid body, which will apply to your characters, and that rigid body basically sets up physics for that object. Okay, so then gravity will apply. If you collide with other stuff that has rigid bodies or colliders, they will react properly as they would in the real world. Translate, on the other hand, is used for more primitive type games. So Snake, Tetris, Pac-Man, those kind of games where you have to use a fixed kind of fixed step for every movement, and you're not going to have any acceleration, or your speed is not going to vary at all. Okay, those types of games. So your old type arcade games. And also another good example is if you have a game that has physics involved, you will still find some cases where, I mean, it's a game, so it's not going to hold true to real life. You're still going to have like platforms moving left and right, that kind of thing, for your platformer games. And in that case, you can use translate. Okay, you're not going to use apply forces to a platform that's moving across. That's like, a jumping puzzle type thing. You will use translate just to move your object back and forth. But as soon as you need more complicated physics, then translate is not the way to go. Okay, so yeah, that's basically it. So let's see how we do rotate and translate in C#. Okay, let's get started with C#. I'm going to right click the 3D object, create a new cube. I just removed the previous one so that there's no confusion whatsoever. Okay, so cube, assets and scripts. Just come in here and right click, create new C# script, and I'm going to call this rotate. Open that up in Visual Studio. We do not need start, so I'm going to get rid of this. Update. Okay, remember, in between these curly brackets you're going to write your code. So before we get started, just want to rehash something. As I explained in the little animation, we are going to be looking at the transform class. Okay, so on our cube we've got this transform component. In C#, this transform component is represented by a class called transform, and we are going to be looking at these variables: position, rotation, and scale. For now, just rotation, which we are not going to be using directly. We are instead going to be using a method called rotate on the transform class. So position, rotation, scale, that's properties, and it's basically just data. Okay, it specifies where the position is, rotation, and what the scale is. And of course, you need some actions on this to make it do stuff. Those actions are called methods in C#. So let's go and see how we actually use those methods. Let's go back to Visual Studio. We already had a look at a method. This update is a method. Okay, it's an action that's being called, but it's being called by Unity. Every single frame, it comes in, invokes this method, and executes your code inside here. Okay, but you can write your own methods, and you typically write like hundreds and hundreds of methods for like a big game. But for now, I'm not going to get into writing our own methods just yet. We are going to use some of the methods in the transform class. So let's get the transform, and this is a convenience thing. You'll see here there's this thing called monoBehavior. Okay, so our class extends this, and inside this monoBehavior is something called a transform that has variables inside it. And because we are extending it, or this is our parent class, we can access the variables that it wants us to. Okay, so transform is one of them. So we can instantly get transform and call rotate. So if I just hit enter on rotate and open bracket, you'll see this thing pop up here. Now why is it showing us? It shows us one of 6, and this means that there are 6 methods called rotate on transform. Okay, they each do rotation slightly differently. I'm going to go down and look for the one that's similar to what we did on the visual scripting side. And I think this is the one. So we provided an axis, an angle, and space relative to. Okay, so axis. Our axes are defined using a vector3. A vector3 basically, well, long story short, a vector3 has our x, y, and z coordinates. So in this case, we are using it to represent our axes. So on a vector3 dot up. Okay, you'll see there's these convenience things. So there's vector3 called up, which basically means your y-axis. Your y-axis runs up and down, right? Vector3 dot up. I'm going to make the 0.01 f. You have to specify that f, that's a C# thing. If you have a floating point number, you have to put that f at the end. And space. So space is space dot. I'm going to make it self to start off with. And okay, yeah, things are getting a bit complicated now. So just to run through that again, transform, just getting the transform component, and we are calling a method called rotate. And vector3.up is specifying your x, y, or z axis. Up specifically refers to your y axis. If we wanted a x axis, we will say vector3.right, or I think there's left as well. Depending on what you choose, right or left, it will spin either in one way or the opposite way. So let's just try right and see what happens. So this should spin on the x-axis now. Let it compile and press play. And I forgot to add my script to the cube, so just gonna drag this on there. And there we go. It's rotating rather slowly. Now here's one place where visual scripting shines. So if I go back to my okay, it's rotating very slowly, right? So if I go back to my script and change this to 0.1 and save it, if I go back to Unity, it's still rotating at the same speed. So I have to actually stop it and press play again for that to take effect. And now it's rotating faster. Okay, so there's no real-time editing. So if I change anything in my script, I have to stop it and start it again. So that's why it's better to have your speed as a variable. Okay, so that you don't have to come in and keep changing your code to see the effects of any small change to your configuration. Okay, so that's how you rotate, and now let's see how we translate. Let's create a capture this time. I'm gonna move this a bit to the left and down and create a new script. Create C# script and translate. Getting rid of start and inside update. Remember between the curly brackets and the transform. The translate. Okay. Just by the way, if you ever do something like this and you have kind of lost what your parameters are, you can come between these brackets and hit Ctrl+Shift+Space, and it will show you what parameters can be used or passed in. Okay, so I'm going to use this one, just X, Y, and Z, simple enough. 0.01 F. Did I make it 9 point? Lovely. Okay, 0.01 F, comma 0, comma 0. And that will move along the x-axis. So this is x value, y value, and z value, separated by commas. And that's how you pass different parameters into a method. And okay, let's see how this looks. So capsule selected, make sure the script is on there. I'm going to drag translate onto it and press play. Okay, there we go. It's moving along. If I want to change the speed again, I have to go back into Unity and change that value. Okay, this is bad programming practice, so let me just show you how you should actually do this. You should create a variable. I'm going to call this public float speed, and this will show up in Unity now. Okay, so we've got translate. I'm going to make speed 0.1 this time. And instead of using the value like this, so when we specify a value like this, just plain outright, we call this hard coding. Okay, specifying a value like this, we should actually use a variable, and this makes it configurable. And the main advantage of this is if you change something, you don't have to come in, make a change every single time, stop and start. You can just go into Unity, compile, press play. Okay. Now I don't have to, if I want to change that speed, I can just change it right here. 0.01, press play. And while it's running, I can actually go and change that. So you can see just dragging. It's very sensitive. So if I want to make that slower, for example, I'm just going to add another 0 there. 0.001. And that makes it easy to test this thing and change the configuration at runtime. The only thing you have to keep note of is with visual scripting, it will have kept the value that you've changed here, but with C#, because this is a C# script, if I stop this, you're going to see this is going to change back to what it was before we press play. And you see it changed back to 0.01. So that's something important you need to keep in mind, because that can lead to some really frustrating experiences, but you get used to that quickly enough. Okay, I hope that wasn't too much to take in. I will be going into a bit more detail about properties and methods in another lesson. I thought we'd just do something a bit more interesting today. So yeah, just let me know if you need more explanation on anything else. Yeah, just drop a comment below, and until next time, enjoy. Actually, before I go, let's have a look here. So C#, this is not exactly the prettiest thing to look at. So I mean, I've been looking at this forever and ever, but just trying to be objective here. Transform dot rotate factor 3 dot right 0.1 amp space dot self. That's yeah, if you're not used to this, it can be a bit difficult to follow, compared to if we go back to our visual scripting example. I mean, this is just so nice and easy to see what's happening here. You can see it accepts a transform, or where it needs to rotate around, which axis it needs to rotate. At least this first one is which object it's going to rotate. By default, it's whatever object the script is attached to, axis, the angle, and relative to self. I mean, this is just so simple to look at. If we look at translate, okay, this is a lot easier. Okay, just transform dot translate speed 0,0. If we look at translate here in visual scripting, okay, it's a lot easier to see that, okay, it's translating itself on the X and Y axis, and Z axis is nothing. So yeah, not much of a muchness here for these two. I mean, it's easier to see what the variables are, X, Y, Z, as opposed to just looking at this. I mean, you have to go in and press Control Shift Space to see what each parameter is, and there we'll see it's X, Y, and Z. Okay, so yeah, for this one, I think I might actually give it to visual scripting. It just felt a lot easier to get things up and running, and looking at the code, especially looking at this rotate example, and when you come here and having to see, okay, what all these different methods are for rotate. I mean, there's a bunch of them, there's 6 of them, whereas on the visual scripting side, you just see a nice simple pop-up. If I go and look at rotate here, yeah, you get a nice list and you can see exactly what's happening. Okay, as opposed to having to cycle through each one, but that's also just Visual Studio. I think if you use Rider, it might be easier. But Visual Studio is what we're using as our baseline, so yeah, I'll definitely give this to visual scripting for now. As things get a bit more complicated, I think I'll swing back to C#, but this is a very simple example, so just keep that in mind. Okay, I'm done now for real. Until next time, guys, enjoy it.